Good morning, everyone, and welcome to the Faster SOQL Yes Please session. At Dreamforce, I'm assuming everyone has seen this slide. It's our safe harbor slide. Please don't make any purchasing decisions on any potential future-looking statements that we may make. Please make purchasing decisions on currently available features. So I'm assuming you're here because you use Salesforce and the Force.com platform. You're a developer or an architect, and you want your queries to perform well. And before summer 14, you probably, how many of us have used debug logs to look at how fast our queries perform? All right. Well, today we're going to talk about how we can use the query plan tool to give you a better idea of why your queries ran for that period. We'll talk about making sure that you add selective filters to your queries. And so we're going to talk about the query plan tool, which is in the Dev Console. My name is John Tan. I'm an architect evangelist in our customer-centric engineering team at Salesforce. And part of our charter of our group is to provide a lot of best practices content. On the developers community, there's an Architect's Core Resources page, and it has a wealth of information on topics about query performance, sharing, record locking, issues that you'll normally hit when when your data volumes grow. A lot of you here may have written queries that perform really well now, but as we all hope, your business will grow. Your records will continue to grow into the millions, and that's where you could potentially start having issues, as well as the fact that if you had a unselective query in your trigger, you might be hitting limits. So today's session will help you write selective queries. Also on the Architect's Core Resources page is a query cheat sheet, which you can download. It has a lot of information that we'll cover today. I'll leave that up for a second. And at the end of the session, a lot of these links will come back again. So you'll have a chance to take a photo then. And with me today is?
Hi, I'm Chris Peterson. I work for FinancialForce.com as a senior software developer on our professional service automation application. And I'm a Force.com MVP. So John said we're going to introduce the Query Plan API. And the blog post of this session was initially based on, we built our own client for it because it was an API only in Apex and Visual Force. In the blog post that's linked right there, you can grab that source on GitHub and use that if you prefer. But I'll show you the easy way to go enable this in your org right now without installing a managed package. To do so, pop open the developer console and go to the Help and Preferences menu. And then you can turn on the Enable Query Plan tool via this option right here. And once you've done that, the query editor pane in the developer console has this new button called Query Plan that will enable you to view those results without having to build an API client or install a managed package.
All right. So before we look at the tool, and we'll have plenty of demos, let's provide some background information. So as I said earlier, the goal here is to write selective queries. So in order to write selective queries, you have to understand what the Force.com Query Optimizer is and what it's doing. So whether you're writing SOQL reports or creating reports or list views, that's going through the Query Optimizer. And the Query Optimizer is producing the most efficient query possible based on the inputs you provide. And the Query Optimizer is going to try to produce the most efficient one. But it's important that you provide filters that are selective. Give it some help. So how does it work? Well, the optimizer does this by looking at pre-computed statistics. It looks at the indexes or skinny tables that are available, and user visibility through sharing is always involved. So the basic algorithm is that the optimizer uses a pre-query engine to get statistics, and then it scans through your where clause and looks at each individual filter itself. And it'll select the most selective filter, as well as the fact that it does some optimizations. So it may combine some of your filters, and we'll cover this with some examples later. But the key here is that you want to help the optimizer make the best choice on how to run the query. So you want to make sure that you have selective filters. So the goal here is to have one or more selective filters per your SOQL statement. And so how do we know, or what's the components of a selective filter? Well, you want to make sure that you add filters, and you want to avoid some inefficient operations within your filters. And we'll talk about the selectivity thresholds that your filters have to meet. And then lastly, if those fields in your filters aren't indexed, get them indexed. So what are some fields that make good filters? Right? Date fields, pick lists, and you want fields with wide and even distributions. So, a checkbox is not going to be a very good field to index, right? Because you're going to have a 50-50 distribution most likely, or it could be skewed. And as we'll discuss later about the selectivity threshold, it's most likely not going to meet those thresholds. One thing you also want to avoid is non-deterministic formula fields. So by non-deterministic, we mean that when you run that query, the value could change. So if you were using, say, the today function, whenever you run that query, the values change. So it's a non-deterministic formula field. A very common example is when you reference a related object. That's non-deterministic and will not use an index. There's a great blog in the Architect's Core Resources Library on formula fields and query performance. So I talked earlier about a couple of inefficient operators. So you want to make sure that you don't do any negative operations. So a not equals, not contains. With the optimizer, it realizes that when you do a negative operation, you're more likely to match a large number of records. And it's more efficient to just scan the table instead of using an index. So you want to use reciprocal values. So instead of not equals closed, you can do a equals or in with the reciprocal values. You also want to avoid leading wildcard searches. Here's another example where the optimizer can't make an efficient query based on a leading wildcard search. SOQL doesn't support leading percent wildcard searches as well, but SOQL is a better way to do searches. That's what it's built for. If you really need to do SOQL type searches, I would say develop a custom Visualforce page and add some governance on the type of fields that you can search on, have a limit on the number of characters, a minimum number of characters before you do searches. Okay, so earlier I mentioned the selectivity threshold. Essentially, the optimizer is trying to determine whether using an index is efficient. So if your filter was returning 90% of the rows in that object, the optimizer realizes scanning an index for 90% is less efficient than just doing a table scan and getting all the records in at once. So with a standard index, there are 3 rules for the selectivity threshold. The first rule is less than 30% of the first million, and then less than 15% of the return records after the first million, but you're maxed out at 1 million records. So if we had 750,000 account records, the first rule applies here, which is 30% of the first million records. So the selectivity threshold, if you had a filter for this account record, would have to return less than 225,000 records. If you had 3.5 million records, the first 2 rules apply. Less than 30% of the first million records, and then less than 15% of the remaining records, which gives us a selectivity threshold of 675,000 records. Once you go over 5.6 million, you're capped out at the 1 million records. With the custom index, it's basically a third. And so the rules here are less than 10% versus 30, and 5 instead of 15, and you're maxed out at 333,000 records. So here's some fields with standard indexes. Master detail records, lookup fields, record types. But more often than not, you're going to need custom indexes. And so the key here is to plan for this. right? You want to make sure when you're doing your development, you think about the types of queries that you're going to be making, right? If there are a set of fields that you're always going to be filtering on, get single or two-column indexes created by customer support. And you'll be using the query plan tool to help determine the selectivity as you're deciding on whether to index those fields. And once you do have a set of those fields that need to be indexed, contact customer support. So in conclusion about selectivity, selective filters, a filter condition is selective when it uses an optimizable operator, it meets the selectivity threshold, and it's indexed. All right, Chris.
All right, so with that, let's dive into what the query plan tool gives us. So I've preloaded a query in here, just a simple one, select ID from contact where created date is greater than this year, so that we can see what the query plan tool shows us as a result. And so it tells us a few things about this query when we run it. So column by column, it tells us the leading operation type, which is the type of optimization the optimizer is applying. A table scan is looking through every row in the table. An index is leveraging either a customer standard index, et cetera. Field is populated on any index operation and some types of other operation. So there are some types of leading operation types that are internal Salesforce optimizations, and the exact methodology isn't disclosed. Some of those may have fields that are field indexes being leveraged as well that would show up in the fields column. For S-object type, you naturally think that that is the S-object type in the from clause of your query, and it generally is, but in some cases the optimizer decides it's more efficient to query against a related object if you have filters on it, and then join to the object your query is actually against. So that can change if a relationship filter is being used to optimize the query. S-object cardinality is an estimate, much like the data usage page, of the total number of records in that table. Cardinality is the query optimizer's best guess, and it has some internal optimizations that make it not a concrete number of the total number of rows that would be returned by the query. So it's very useful for comparing to the S-object cardinality number for seeing if you met the thresholds that John just showed. But you shouldn't use it as a replacement for something like a count query. Lastly, and probably most interestingly to anybody worried about selectivity, is the cost. And this is relative to the number 1, which is the selectivity threshold. So having a cost of less than 1 means that if the optimizer used this operation, it would be selective. If it's greater than 1, it would be non-selective. So let's set the stage for a more complex query we can optimize. We'll set up the business case first. We have a support manager flying in from out of town to our San Francisco office. And while she's in town, she wants to visit everybody who has open cases that's within driving distance of the office. We also want to do some things like be realistic about her time demands and say, let's only meet with people in management roles, and let's filter out any accounts that are discontinuing service. So when we put all those together with our org schema, we came up with a rather complex query that meets all these criteria right here. And it's a pretty big, complex query that has a number of subparts. So let's throw that at the query optimizer and see what it can come up with. And it gives us some interesting information, but possibly not as granular as we're looking for if we're looking to optimize this query. It tells us that a table scan is leading operation type. It considered an index, but there was too much data skew or some other reason why it was not the leading operation type. And then there's that other, an internal Salesforce optimization. But since they all have the same cost, it went with the table scan. It's not selective, so let's see what we can do to work through that. The first thing we can do to just cut this query down and be visually and conceptually simpler to understand is realize that while selecting a number of fields, especially cross-object fields, subqueries, can impact your query's performance and total execution time, they don't actually play a role in calculating selectivity. So the very first thing we can do is remove all that and cut it down to just a select ID. And when we run that, we see the exact same results of the query plan tool. So just to keep our example simple and keep it conceptually simple, we're going to stick with that for the rest of this demonstration until we put it all back together. Next, we move on to our filter on account, making sure that your account is not attired. We pull that up in the query plan tool. It tells us that the only way that it can think of how to apply this filter is through a table scan, and that's due to the negative operator that we just learned how bad they are. The relative cost is 2.8, so it's nowhere near selective for that filter. We can take the advice John just gave us and change that over from a not equals operator to the other value in our pick list, live. And when we do that, dropping the negative operator, even though it's the same result set, our cost went from 2.8 to 0.8. Still a table scan, but what I talked about earlier, where the S-object type might be different if it's doing a join the other way around, is happening here. It's querying the account table, which doesn't have anywhere near as many records as our contact table does, finding the result set, and then joining to the contact table then, and that's how it's achieving that much, much lower cost with a table scan operation. We also see it considered an index on the account status, but since there aren't enough accounts in our database, it went with a table scan instead. We didn't meet the 10,000 rows threshold for data to really be enough to consider other operation types beyond table scan. So one thing to keep in mind when you're using this tool is that if you don't have at least 10,000 rows in the table you're working on, and optimally it's much closer to 100,000, the results you're going to get back are almost always going to prefer a table scan because there's so little data, it's faster to just sift through it in memory than it is to worry about applying an index to it. So when you're using this tool, try and do it in something like a full copy sandbox, a developer org that has quite a bit of data. You can run the query plan tool against your production organization to also get some useful statistics there. So now that we've optimized that clause, let's move on to the clause that we have, again, looking for people in management roles. So we've implemented this using a like operation with a leading wildcard, trying to match any strings like manager, management, any of those. So we have a leading wildcard and a trailing wildcard. And when we put that into our query plan, we see it's still preferring a table scan, even though there's enough data in our organization that it probably should be looking at an index. And that's because the leading wildcard. So we learned that they're bad and that they're really performance killers. So what can we do? Well, we can take the reciprocal of that list, which we have right here. And that's the conventional answer to this problem. And we get a much, much lower cost on this filter. But there's another option that I picked up from a few real-world altercations. Let's step back and add an additional constraint to our use case. This pick list, this role pick list in our org is going to be changed by admins quite often. So trying to maintain this reciprocal value could be a heavy load on our developer team, especially if it's in something like an Apex controller where you need a deployment to update it. The admin team doesn't want to have to do a deployment every time they change that pick list value. So what can we do that gives us the leading wildcard operation, but without the performance drain? And the answer is a deterministic formula field with a custom index. So we set one up here called isManagement, and really we're taking a page from Salesforce's own playbook with the isClosed field on case. If you're not familiar with it, there's a customization option called support processes, where an admin declaratively says, these case status values are closed and these ones are open. Well, we've tried to emulate it as closely as we can for our pick list without trying to leverage a custom setting or something like that. And we apply a contains operation, the exact same logic our leading wildcard operation had. And since we've requested a custom index through support, when we run that query, a much, much lower cost than the table scan. So which is better for your situation is highly dependent on your organization structure, your schema, your admin roles and responsibilities. But you should be aware of both options and definitely consider leveraging indexed formula fields where you think it's appropriate. Moving on, we have something that's relatively new to the platform, a geolocation field. We're only looking for customers that are within 50 miles of San Francisco. So let's see how that distance function works for us. We get a relative cost of 1.2 from a table scan, and that's not too bad. We already have a couple selective filters, so we're not going to worry about it too much. But since a few releases back, it's actually been possible to apply a custom index to a standard geolocation field or a custom geolocation field. So if we are worried about future scalability, that's one option that we have, is to request through support that we apply a custom index to the mailing address field on contact here. And that would drop the cost of this filter quite a bit. As our data scales, it would probably be a very wise thing to do. And then we have the last filter, a semi-join to the contact table, looking for cases that are not closed. We put this into the query plan tool, and it gives us something that's interesting. A table scan on contact with a cost of 2.8, and an other operation on contact with a cost of 2.8. Well, we're really interested in figuring out how to optimize the query on the case object, because that's what's really that's the goal of this filter in particular. So what we can do to simplify this even further is change this from a semi-join to just a query directly against the case table. And when we do that, we get some more granular information. It tells us how the case table would be queried and statistics about that might be a little more actionable to us in our specific situation, trying to optimize the parent query and all of its filters. So we have a relatively low cost, but that just happens to be because there's not much data in this table yet. So we want to optimize that because we know we're going to have a lot more cases in the future. And the first thought would be to change the status to equals open or something like that. But then we remember what we just learned about the is and how we want to make this as maintainable as possible. So let's switch over to using that. Run our query plan, and a dramatically lower cost by leveraging that. And also we have the additional benefits to maintainability. So if we put all these lessons we learned back together into rewriting this full query, putting all the fields back and all these optimized clauses, we end up with this query right here. If we remember, our old query was not selective. Our new query is highly selective with a cost of 0.01. Although that's largely because we don't have too many cases yet. As this scales, it's going to be much closer to that 0.6 number we see. But still, we went from a non-selective query to a selective query with almost no administrative burden that some of the traditional optimization techniques might have had in our org with all the constraints that we applied to it. But I do have one question. What's that leading other type? What could that possibly be?
Well, as Chris mentioned earlier, the leading operation type has index, sharing, table scan, or other. And other is an internal Salesforce optimization. At this point, we're bucketing a lot of optimizations into that other bucket. We may expose some of that in the future. But I would say instead of worrying about exactly what the other field stands for, focus on the relative cost. Right? The key here is to drive down the cost of the query. And as we said earlier, the optimizer is trying to make the most efficient query possible. So it's using each component of your filter, of your word clause to try to generate the most efficient query. But I can tell you about some of the optimizations that's going on behind the background. And one of them is when you have a bunch of AND clauses on index filters. So let's assume that we have indexes on first name, last name, city on a custom object. And so here, when we have an AND condition, the query optimizer is going to do an intersection of the indexes. So the first step that it does is that it allows each one of those indexes to go 2 times the selectivity threshold. It does that because it knows that when it tries to combine them later, it's going to have a lower number. So because it's an intersection, we're going to say, okay, 2 times selectivity index for each one of these, and then we're going to intersect them, but you still have to meet the selectivity threshold afterwards. If all these filters were standard index, the standard index selectivity applies. Otherwise, the custom index selectivity threshold applies. So let's look at an example. So as I said, we have a MyUser object with 100,000 records. And so in step 1, each one of these filters has to return less than 20,000 records. Let's assume that first name Jane returns 3,000 records, the last name Doe returns 250, and San Francisco returns 12,000 records. Each one of those is below 20,000 records, so they meet the criteria, and the intersection is 2 records, which is definitely under the 10,000 records. Now let's say Jane returns 20,001 records. So here, it doesn't meet this criteria in step 1. But the optimizer, as we said, is trying to generate the most efficient query. So here it goes, okay, let's just use the other 2 indexes and do an intersection of that. So here, it'll still use, and we call this a composite index join. So that's occurring here. But if this is always happening, and you know that you have a set of filters that are always being used, a set of columns that are always being used in your filters, just have a 2-column index created. That way the optimizer doesn't have to go through this additional step. When we have OR conditions, let's say we're using the same 3 index fields, we're going to do a union. So here the difference is in step 1, we're not going to allow you to have 2 times the selectivity threshold because we're not doing an intersection here, we're doing a union. And just like I said earlier, standard index, if all these were standard indexes, the standard index selectivity threshold applies, otherwise custom index selectivity. So let's go back to our example. All right, same results. First time, 3,000 records, 250 and 12,000. They all have to be below 10,000. So here, the index on city, that filter doesn't meet the criteria. Therefore, the union of this won't as well. Chris, do you want to show us an example?
Certainly. So we can hop back over to our developer console. Was that, oh, enlarge the screen? Certainly. Any better? All right. So we have an example that uses an index join prepared right now. We're looking at contacts where the status field that we've applied a custom index to is equal to active, and the role is equal to executive management, which also has a custom index applied to it. We look at the query plan. We see the leading type is other, which would be that composite join operation that John was just telling us about. Takes the 2 indexes that we see with a 0.3 and a 0.5 selectivity threshold and gives us an even better, or not selectivity threshold, but selectivity, and gives us an even lower cost of 0.19 as a result of joining them.
Thanks, Chris. Excuse me. Another optimization that the query optimizer does is sort optimization. So if you were trying to query, say, the most recent opportunities closed or won, and you had an order by clause on an index like created date, and you had a limit clause. The optimizer realizes that it can scan the index and stop at a certain number. So you need to have an order by on a date or number field, and the result has to be bound by a limit clause. Chris, want to show us another example of that?
Certainly. So much like John's example in the slide, except actually occurring in a real org, we're ordering by the created date and applying a limit to that. This is going to cause it to look at the index and just say, what are the first 100 records? It's a very efficient operation under the hood. When we run the query plan, we see a very, very low cost other option because of how efficient it is to just say, what are the first 100 things in the index?
Okay. So in summary, we want you to realize that the query optimizer is going to generate the most efficient query possible. Make sure you add at least 1 selective filter to your SOQL statement, and make sure you test with more than 10,000 records. As Chris said, 100,000 would even be better. And here are the links that, so Architect Core Resources Library, the query cheat sheet, our wiki article, and also the blog on the sort optimization. And we're open for questions.
And as a first answer, yes, we'll put these in the chatter for the session.
There's a microphone, sir.
So one of the things I noticed in the little teeny footnote about null, I have an issue with a date field, a custom date field, and I need to select stuff that is not null in that date field. Because I'm not looking at a particular time frame, so I guess I could have said greater than 10 years ago or something like that. But even then, as it looked like there, it won't work well if you have null in your dates.
Well, I can't remember which version of our product, but we do have the ability to create indexes with nulls now.
Oh, we do? Okay.
Yeah. So that could potentially help.
Of course, it's a managed field, so I can't put an index on it anyway. So that's a different issue.
Well, you can have the index applied in a customer org, but you can't package the index.
Right.
Yeah, there is a blog post that announced the ability for deterministic formulas and nulls to be included in indexes on the architect evangelism section of the Developer Force Wiki. That should have a little more detail about that.
Thank you.
Hi. Which would be better? I've got a composite requirement where one field's got equal one specific value and another field is equal to null. Would it be better to ask for a composite index on that or to create a formula field that should be indexed?
So one of the tricks that we can do as well is when you create a two-column index, if the second column is your null, that'll work. So have customer support create a two-column index where the first column is the non-null and the second one is null.
And that's better than the formula being indexed.
Well, I mean, it'll save you from creating the formula.
Okay, thank you.
It's probably too dependent on your data for us to give you a blanket answer.
Right.
There's probably nothing wrong with trying both ways and asking support. They have some pretty advanced tools behind the scenes that can tell them, if you say these are the two options I'm looking at, what do you think? They'll give you some feedback on which one's the better option.
Okay, thank you.
Okay. So my question is, I have a huge Apex class which has a lot of queries inside it. Can I run the query plan on a class, or do I have to pull out all the queries and go to the developer console?
Yeah, this tool is only for individual SOQL statements. And Safe Harbor, we're also working on adding report and list view IDs to this tool as well. But unfortunately, you can't just assign it to an Apex class and have it automatically run.
Okay. The second question I had is, when we use the query plan on the developer console, should it be a static query or can it be a variable assigned to a where clause?
Yep. You can't use bind variables with this tool at the moment. Actually, one of my feature requests, if I ever get to meet the product manager behind this, would be specifically for an Apex-based version of this so that I can test bind variables against it. Because there are a few edge cases with bind variables that aren't possible with static queries. So yes, there's definitely value to that. It's definitely an ask that I have of the team as well. But no, there is no way to invoke it from Apex right now. And under the hood, the developer console is making a REST API call. So there'd be no way to encode that bind variable.
Okay, thank you.
I hear that you can create external ID, flag a field as external ID, and that creates a index. Any pros or cons of that, or any recommendations?
So I would recommend that you work with support to create a custom index because there's some special functionality that happens with external IDs, and you also have some limits. So I would say I would recommend using custom indexes.
Yeah. And as a supplement to that, as an ISV developer, I'd say the only exception to John's advice is if you are an ISV developer, you're releasing a managed package, and you want to have that index applied to every customer install, then leveraging external ID might be the right choice. But if it's just for your organization, I would definitely go with a custom index over trying to use an external ID.
Right. And going back to like earlier statement about managed packages, I mean, we get that a lot from ISVs. They want an automatic way to create indexes for their managed package. We're also looking to see how we can make that happen. But also behind the scenes, when the query optimizer is collecting nightly statistics, one of the things that we're also doing is looking at which queries are run the most and whether we can automatically create an index for you. So if you happen to request an index and support says, oh, we've already done that, that may be one of the reasons why I haven't.
Why do we have to go through support? I mean, I don't know, why don't they build a point-and-click solution for?
I don't have the history of why that would happen, but part of it is the fact that it's a multi-tenant environment, and we're not exposing, the data at the database layer, and giving you the option may, we have statistics, and the optimizer knows how to generate the most efficient queries, right? So by allowing the customer to create indexes, you potentially could run into problems with, say, your DML statements being a little, slower, right? So even within an object, internally, we have limits on the number of indexes that you can create on an object. So a lot of it is just how we store data and how our optimizer works.
So support does some kind of analysis that maybe an index is not needed. I mean,
Yeah, exactly.
if I say, okay, get an index here on this field,
Right.
they would, check that if it's a valid reason for that or not.
They effectively have an internal version of the query plan tool that gives them some additional information. It drills down into some implementation-specific details that aren't exposed to the API yet. But yeah, that's exactly what they're doing, is looking and seeing, well, if I applied this index, it's a what-if version of the query plan tool. If I applied this index, what would it do to this query? And yeah, as John just alluded to, adding additional indexes makes every DML operation slower, because conceptually you have to think of it as each index is grabbing a copy of the field that's indexed on each DML operation and applying it to the index. So if you start having too many indexes, it's spending more time updating the indexes than it is reading from them. And there's also some internal details about the way indexes work in Salesforce that I don't fully understand myself that make it so that if you have if you have indexes that are actually not helping make your query selective, they can actually hurt performance a little bit. So indexes can be a double-edged sword if used improperly. And realizing all the things I have, I'm actually glad we have support in the way of, and not letting us create our own, because it's too easy to back yourself into a bad position.
Right.
Okay. I guess the creates could get slower if you have too many indexes or something, right? I mean, I'm thinking in terms of a database.
I'm sorry, could you repeat that?
The creates could get slower if you have too many indexes.
Well, inserts, updates,
Insert,
right?
right.
Yeah, DML operations themselves.
It's similar to the reason there's a limit on field history tracking, is because if you track too many fields, it spends a lot of time keeping track of each field on each DML operation. And much like indexing, support can raise that limit if you're willing to accept that. But yeah, there is a cost to indexing, is effectively the answer.
Thank you.
Sure.
Is there a way to find out which, like if you've ever had a custom index put in, can you still contact support and they'll let you know which ones you have? So for example, if you come into a new organization, you would be able to know which ones are already there?
Yes, and so I'm working with the Scrum team right now, where we've exposed which fields are indexed. The team that implemented it has hidden it behind a perm, so you have to request it from customer support, so that admins can see which fields are indexed. I'm trying to get that safe harbor, turned on for everyone.
Do you know the name of that permission offhand?
I'll tell support.
Okay.
Yeah,
And it might be
I
a
don't
good
know,
thing to put
yeah.
in the chatter group so that people ask for
Right.
it. It can be unambiguous.
Yeah, I think we have to work with support because, unfortunately, I don't think when they released that feature, they released any documentation on it. So support wouldn't know until I put in a knowledge article for support.
Okay.
But yes, you will, safe harbor soon, see, you don't have to contact support to find out which fields are indexed.
And if you find that there's some that are no longer necessary, can you request that they remove it?
Yes, by all means.
Okay.
That's one of the things that could come into play where, as I said earlier, the query optimizer is sometimes creating custom indexes for you. Or you may run into the situation where you're at the limit for an object, right? And some indexes aren't really necessary anymore, but we can't automatically create one for you, right? Because you're at that limit. So I think having, planning for queries as well as maintaining them and maintaining indexes are important.
All right. Thank you.
Sure.
And if you have too much free time on your hands, you could probably use the query plan tool to try and figure out which indexes are applied, but I definitely recommend contacting support instead of doing that.
Oh, you wouldn't want to do that. They're on our task object, and we have lots of those.
All right. Any other questions? Well, thank you.